So are you ready, Glennie D? We are
Ready,
preparing our
ready.
live stream. And I'd have to say, I think we're live. Good morning, everyone, or whatever time it is in the world joining us. Here we go.
We're getting a little bit of feedback there, Miss B, some technical issues.
We are live.
Sometimes things go wrong in space.
We are live. That makes it official. All right, fantastic. I think we probably should just get started with our fantastic project that we're doing today. So many of you will know that Glennie D has immersed himself very deeply into looking at how plants can grow in space. And really all types of habitats in space that will allow us to have a home on the moon or industry, and also on Mars. So they're the two planets at the moment. But because Glennie D has immersed himself so deeply and he's been listening to podcasts and talking to specialists and going live into schools and helping students with their designs for the Australian Virtual Astronaut Challenge with physics education and Magnitude.io and the New South Wales Department of Education's STEM Industry Schools Partnership Program. Wow, there's a lot of people involved in this. So let's go through what you found and some of the prototypes and the best products that students can access to actually have these scientific experiments happening in space. Very exciting.
Hi, thanks so much for joining in, and thank you, Miss B, for that introduction. We have had a really busy week, and I'm so excited by what I've been learning from listening to people like Ted Tagami from Magnitude.io. And
students too, because one of the primary things that they told us is they wanted to see devices above all other designs in their poll.
Yes, and that's why I thought today we'll give some students and teachers the opportunity to draw along with me, and we'll draw some scientific apparatus for the purpose of growing plants in space. ExoLab send science experiments into space and up to the International Space Station, and lots of classrooms in the US and in Australia through Physics Ed have the opportunity to obtain this equipment and repeat those experiments. Mm-hmm. So we're growing plants in microgravity. Can you think why, Miss B?
Well, I kind of know, Glennie D.
Okay, tell us a little bit.
Well, what we want to look at is the ability to be able to have a colony for research somewhere like the moon. Mm-hmm. And I think that means that we'll have to feed our colony. We'll have to find ways that we can live sustainably and self-sufficiently whilst not being able to directly access the Earth's resources.
Yes, you're right, because if we pack all of our food to go to the moon or to Mars or to space, it's going to be a very short trip. Whereas if we're establishing a colony, we need to be able to feed them and to grow that food. So we're interested in what happens when seeds grow. So you can see here, this is what we'll be drawing. This is the scientific equipment, the ExoLab. I'm going to, for the teachers, I'm going to use the demonstration one, pretend that I'm drawing on a whiteboard, mm-hmm. and the teachers can use this demonstration. The students would most likely be using your small splat. And your drawing will be a smaller version, but it will be exactly the same drawing. Is everyone ready to get started?
Well, you start that, Glennie D. I'm just going to do a couple of technical things in the background, and I can't wait. There's so many design considerations to factor in. So I really love what ExoLab have done. So I can't wait. Let's go.
All right. So first of all, we're going to start at the top of the page. Here's my starting point, anywhere around the middle at the top. I'm going to turn the splat upside down. So we're starting at the end today, Miss B, and I'm drawing two lines, 1, 2. Okay, I'm going to rotate the splat, and from the ends here and here, I'm going to draw 2 more isometric lines. There we go. So that is now the top of our device. So let's run a guideline from here downwards. I could use a ruler, or I could use from that little blip in the splat, going to come down, that's 1, just drawing it lightly, And then from the blip, I'm coming down again. That's 2. Okay, so 2 splat lengths. Now at the bottom, I'm going to draw 2 isometric lines. Boom, boom, and we're almost there.
Fantastic. That is a very light line. The students may not be able to see that light line at home.
Okay.
You normally draw in pen. So
this one here is very light.
Yeah.
Okay, well, let me grab a ruler and I'll just go over it a little. So there's my line because I can erase it later.
Mm-hmm.
I'm going to join these 2 corners and these 2 over here. All right, so that's the outside of the container. That's about the size of it. And what we're going to do is to draw what we'll call the cap. You can see how I've labelled this, Miss B.
Mm-hmm.
If you were drawing anything for STEM, it doesn't need to be an Exo Lab. The skills that you'll learn by drawing this and labelling it, you could use for any of your assignments.
Yeah, the labels are also, when we make notes about our designs, often called annotations. Great way to document your evidence when you're designing and also give people a bit more detail about what you're thinking with your design. I love annotations.
So here we have the cap. Let's draw the base. So here's my original position. We'll just come up a little bit and we'll draw in the base. It's pretty easy with a splat there. Okay, so let's draw in the back. So there's a camera in the back here and some electronics and things, so for all the data logging. So let's go ahead and come across a little bit. You can change any of these measurements to suit yourself and draw a line there. I'm going to connect, this will be the one component. So I'm going to erase this line here.
I would imagine though they'd have to justify why they moved that camera. So the camera is viewing a particular parts of the growth and
yes.
the actual like environment within that unit, right?
Yes.
So we'd have to justify anything that we change there.
True.
And these units can be, you can get them from Exo Lab. So that's Magnitude IO, that project. I'll make sure I put the link below. Ted Tagami and his team have developed these. They're pretty cool. A bit like Invertigro too, the Australian modular units that they're using in space.
Yeah, they are fabulous. Look up Invertigro. So what I'm doing now is to draw in the growth containers. These are the tubes that the seeds, the clover seeds, will grow and sprout in. They contain like a jelly mixture. It's made out of seaweed, and that's what the roots will grow down
Agar.
into, hopefully.
Yeah,
Agar.
Really simple.
We don't know whether in space whether the roots will grow upwards, will they grow sideways or down into where the moisture is in the agar. So that's what we're doing experiments on. Okay, also we found out from Ted Tagami that these plants are really important because they fix nitrogen using bacteria. It's a symbiotic relationship, and it produces nitrogen for the plant, and the plant feeds the bacteria. So
that is cool.
Yeah, we need it on Earth, and we're interested to see if that happens in space, that symbiotic relationship. Okay, so let me quickly whiz on now, and what we're going to do is say halfway between here and here, I'm going to place a mark. I'm going to use my isometric line. Notice I've got the splat straight up and down. So I'm going to draw a line back there. Now, on that line, I'm going to place 2 marks, maybe 1/3, 2/3 along that line. So here and here will be my centers. Now, this is the one time I'm turning my splat, and those yellow marks I'm turning straight up and down. So I'm making sure that this ellipse is vertical. And now I'm centering it on that first mark. I'm going to draw that in. I'm going to do the same thing over here. There we go.
Can you just show the students the smaller splat, and you'll see that on the smaller splat, the actual tool there, that one, that those blips are not a different color, but if you run your finger over it, you'll see that those lines are actually blips on the top of the splat, which will help you line that up. So don't worry, you probably can't see that here, but they are on the smaller splats as well. They're
That's
just not
a great
colors.
point. Yep. So now what I'm going to do is to place a ruler on the very edge of this ellipse. I'm going to run a guideline up. So what I'm going to do now is draw the top. Now, what I'm doing is lining up that ellipse with this line, and I'm moving it up, I'm moving it up. If I keep going up here, it disappears under the cap, and that's okay, because using overlapping is a great way to get that 3D effect. All right, so we have that one. Let's do the same thing. We'll run some edges of the growing tube up and up. And at the top there, going to maybe draw in just a hint of that one under there. All right, cool. So we're missing 2 lines, Miss B. One will come from here and will come backwards. So let's draw that in. And when we hit the tube, we'll stop.
That will clarify the base for the students of the actual unit itself, which is good. From this
side. Let's go back until we hit the test tube, maybe a hint in there. Okay, so that is pretty much the basics of the apparatus. Let's draw the seed in there. So we're going to maybe halfway up. Let's draw the top of the agar. And where shall I draw this one? Well, remember, using that isometric line, that is what actually is level in the real world. So we'll draw that one in there. Let's draw a seed on top of there.
Now, we also have been working with the Imagine Naturalist, who is an incredible scientific illustrator. Yes, amazing. And so in the project, the Virtual Astronaut Challenge, Australian Virtual Astronaut Challenge, there is also available worksheets and information from her about plant biology and observing plants and illustrating them for our scientific knowledge. So that was really cool too.
Going to show you really quickly these plants. They would grow under white light, but not all of the wavelengths of white light are needed, are necessary. So we can use, that's why sometimes these plants, you see them growing under purple lights, violet, or under a reddish type light.
There's purple lights with the ExoLab 9. I have seen them. So yeah, very cool.
I don't have purple. I'm going to use just a little bit of chalk or a soft pastel, and I'm going to just kind of represent that light. So I've used some Post-it notes to cover, and I'm wiping off the Post-it note. Don't make your first wipe really, like, often the first wipe has too much blue in it. So what I do is just to go pat, 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 and then wipe off. And if you want a nice fade, that's a great way to get your fade. So here we go. Let's wipe off there. And now I'm going to just give a little bit of a roundy round there. So this is like the blue light.
Is that a technical term, roundy round?
Actually, when the light hits the agar, you may also get a little bit of light. So let me just do a little bit in there. Okay. So if I take those off.
Looking how light works, that's great. So that's a really easy way that you can create a mask to give that effect.
Yep. Now, because this is such a big drawing, if you're a teacher doing this on the board, you'd be using a whiteboard marker. So what I'm going to do is just to whiz around the outside with my thickest line. This is called a cutting line. This helps the drawing stand out on the page. And what I'm going to do next is some lighter lines. So there is my heavier lines. Just going to flick that one there. Sometimes when lines disappear, it makes it a bit more interesting. That's the art sort of side, I guess. Now we're going to go for a thinner pen. If you were a student, you could use just a black pen to go around this, or a felt tip. And what I'm going to do is to quickly draw in my other lines. So do one there. This one's a slightly thicker line because it's the meeting of 2 different components. That will get a thicker line as well. And down here.
So the students don't have to just draw a device. They can actually draw other products. Sorry, I shouldn't just say draw, design. So we are actually looking at designing all different types of products. Drawing is just probably the quickest and easiest way that we currently have to visualize our ideas. So that is why it's such an important part of the process to make sure we're communicating what we actually want to see.
I'm actually going to use a blue pencil now, Miss B. I can find one. Here we go. Maybe purple, just to show you the idea. So that would be the top of the agar solution there.
Yeah,
cool.
Definitely. It's important that your design actually shows the function. So it is definitely, the form is fantastic, but what is the function and why we're doing it? So we really want to put the detail in, like the agar. We want to make sure that we're representing the type of light, where the camera is positioned to take in the detail. Oh, you might even get fancy and add your own branding.
Yes. Just a few quick things. When this flies into space, we're going to need some way to hold these containers. So if you have a look at the ExoLab experiment, you'll see it. But I wonder if you could design your own method of holding them. Don't forget that when this is taking off, there's 5 Gs, 5 times gravity pushing down on this, pushing the seed down into here. Another thing, how do we hold the seed from floating off when it's in orbit? That's something else that maybe you could look at.
I was just assuming that it'd be like, well, that's right. Or I would just assume that because the agar is sticky that it would stay, but under that different type of pressure, that's another design consideration.
Yeah.
Yeah.
Can we think of anything here? Maybe if you wanted to stop this agar from floating up here, maybe we could have little ridges in the side of the plastic tube, and that would kind of grip onto the jelly. Maybe it has a little mesh here. There's probably heaps of ideas that you could think of. We need to hold the containers. We've got the light. We're going to have a camera at the back here. We may need some little marks on here so that the camera can compare the growth.
Oh, the growth. Yep.
Yeah, to those. And finally, this will be a bit of plastic around here. So what I'm going to do is just with a blue pencil, I'm just going to add a few little marks here, and that represents the edges of the plastic. Could be a polycarbonate, or it could be an acrylic, polymethyl methacrylate, as you'd know.
No, that's a technical term.
No, I'm just
you
smart.
Always swing between really technical terms and really obscure terms.
And lastly, I'm going to show you, to make this look like it's a reflective plastic, what I'm going to do is I'm actually going to just hold my ruler like that, and I'm going to cut through there once, twice, make a wide one, and then a narrow one close to. And that kind of tricks your eye into making it look like it could be some reflective plastic.
We just need to make our plants. So I'm imagining the plants, the color, like chlorophyll,
yes,
light. Are we still seeing green leaves? That's something that Jillian, spoke about. Like, are we seeing the green?
I'd love to know. I can't wait to see the results. I mean,
these are actual specimens from Earth, as opposed to, plants that have actually developed organically in space. So
some green plants and a little. Let's draw some of the roots coming sideways. Or maybe they'll go upwards.
Loved the other day when Ted was talking and he said, like, who knows? Are the plants going to grow up, down, root, like, microgravity? It's very cool. So definitely I'm looking forward to learning more about that.
All right, so cool. And finally, Miss B, why do we want to spend lots of time in space? Why do humans need to go into space?
Well, I think humans have a history traditionally of liking to challenge themselves to achieve the impossible. That's how we move forward, right? But I think what is most fascinating for me as a designer and a teacher is the benefits that actually we discover for the Earth by going into space.
Yes.
When I was a kid, we were always terrified of getting sunburnt here in Australia because of the hole in the ozone layer. And you were saying the other day that, there had been discoveries in space research that had actually fixed the hole, which that's phenomenal.
You're right. Actually, Jim Green NASA's chief scientist spoke very recently about in the 70s, they were studying Venus. And on Venus, they discovered that the atmosphere had been lost through chlorine atoms. And they thought, okay, that's cool. But then in the 80s, we started to see a hole growing in the ozone layer.
Yeah.
It was a big deal in the 80s. And so
were your glasses.
And so scientists recognized what was going on the Earth. It was CFCs. It was the CFC gases in refrigerators and in spray cans. And as a whole world community, we banded together and we stopped those gases being produced. And the hole in the ozone started closing. It actually started healing itself. So planet Earth, we did it.
Yeah. That's incredible. And there's so many other examples. So I put the challenge out as part of your research. Just have a look at the benefits. I think in terms of a dollar to dollar, it's like for every dollar that's spent in space, we actually benefit by 7 times that dollar back here in terms of medical research and earth sciences research. So I think that's quite an outstanding investment.
Amazing. We couldn't live without space. There is so much goes on in space. For instance, whether a country will grow enough one year with it to support themselves or whether they'll need to import. Now, when a satellite flies over a country, it can straight away tell through imaging whether that country will be importing or exporting that particular year. So that has economic reasons. Communications, we can't live without space. And as Australia, we are pushing on. The government is supporting.
Can you tell that Glennie D loves all things space?
Oh, that's so cool.
All right, everyone. Well, thank you so much for joining in today. We hope that you enjoy creating your scientific apparatus for your experiments looking at plant growth in space. If you are part of the Australian Virtual Astronaut Challenge, good luck. And we'd just like to give a big thank you and shout out to ExoLab from Magnitude.io in the States and Physics Education here in Australia for getting together and allowing students to have this fantastic opportunity.
Amazing.
Okay. All right. See you guys.
Thanks for joining in. Bye.